Hello everybody, Dave Shopius here. We are in the robot lab. Well, actually not the lab, we're off in the game room. And today I'm going to be talking about an upgrade I'm doing to my B9 robot. This is my personal robot that I started building about 12 years ago, 11 years ago. It took me about 5 years to do, and it's time to do some upgrades. Today I'm going to be talking about the bubble lifter. Didn't like what I had before. It was problematic. We'll get into that in a minute, but this is where the bubble lifter sits. I call it my lifter chamber. I've already taken a bunch of the stuff apart and disassembled. That's why this is all such a big mess up here, and I'll get into more of that later. But all my stuff is lined up on the CSS, the Central Support System, on top of the legs there. So here is pretty much where the new lifter is going and the old lifter was. So let me walk over to the counter and we'll show you the components, okay? Be right back. Okay, here's a mixture of the new and the old, some of which are going to be used in both builds. First, let me talk about the old bubble lifter I had and why I didn't like it. This basically was the old lifter. It's made up of a support brace that's sandwiched in between the shelves of the CSS. You can see how that would have done. And a servo, high-powered servo, and a lifting fork. So what it did is it would sandwich over this tube here, which is the neck tube. And I had this ring right here which I'm using in my new build, would slip over this pipe. It gets sandwiched by two rings, and that would allow this thing to spin inside that ring right there, the slip ring. And also it had bolts that would stick out and slide up and down on this fork, this lifting fork. So it was a pretty neat little thing. It worked good for many years, but it was problematic in the respect that this servo was very expensive, and it wears out. And I just don't want to be replacing it, and it actually gets weaker as it gets older. So I decided to replace it in my upgrade. So you can see how that worked. It's really, I cut all that myself on a bandsaw and a drill press. So, but pretty proud of it. And like I said, it would sandwich right in between here and lift the neck pipe that would go through these holes here, like that. So anyway, that's how that worked. Like I said, problematic. So as you can probably tell, I am using some of this stuff in my new lifter. This is my new lifting bracket here. It's a hybrid of other models that I see other builders using, namely Greg Loge and JP Sales. So it's a really nice design, and I'll explain it as I go here. But it's different in some ways, as this is beefier. The other guys either don't have the side supports or only have two of them. My bubble area, my bubble is a lot heavier than JP's. And he had two, so I figured maybe for stability and the fact that I'm lifting off center, I would throw another long bearing in here to give it more support. But basically, these stainless steel rods, 12 millimeter, go down into these supports like this. The bubble neck goes in the center there through that slip ring. And when it slides up and down, basically like that, it'll lift this ring. And how does it do that? Basically, another improvement I'm going to do is I'm going to use these slip rings, these thrust bearings on top of the slip ring and below it to kind of sandwich it, to give us some more ability to turn slower, to turn smoother. That's just a bunch of needle bearings in a racetrack that's sandwiched between two washers, and it's very thin, very nice. That will sit on there like that. That'll sit on there like that, pardon me. And this ring here, this plastic ring that I'm reusing from my old bill, will go over here. And the neck tube pretty much go down in between the center of all those. So, one hand. So it's all slippery. You can see how slippery that is. So basically, it's going to give her, when this lifts up, it'll hit that ring there, lift the tube, and then the tube will be allowed to spin inside back and forth. So that's the concept. And then the way I'm going to get feedback on all this to my computer is I'm going to be using a linear potentiometer that goes up and down with it. That'll be mounted in there. So how is it going to be powered? How is it going to be moved? Well, it's going to be, here's my motor I'm going to be using. This is a car window motor for powered windows. It's worm gear. It's very quiet, very strong, and I don't have to worry about the position leaking off when I turn off the power, because these worm gears will hold position. So in other words, when this thing is up all the way and lose power, it'll stay up. If I shut it off or turn off the control halfway down, it'll stay there. Unlike this servo, when I shut power off, the whole thing would just collapse. And I had to have other mechanisms employed to keep it where I wanted it. Basically, I only had one position on straight out, full down, full up. So this will allow me to have any position I want. When I power down the motor, it'll stay there. And it's all going to be powered through a saber-tooth motor controller with a kangaroo daughter board for position and speed, being controlled by EZB and the ARC control software. So now the trick to this whole thing is this offset wheel. I've made it out of acetyl plastic, so it's very slippery, and it is offset on a highly modified cam that I have in there. So you see I kind of cut half of it off, so when it spins, it won't hit the cam, basically. Because what happens here, let me get this out of here, is if you'll see on the bottom here, I have another piece of plastic bolted on there. And this will hit that. And as this spins, the offset will raise it and lower it. So, pretty cool. All right, that's all that works. Let me shut off the camera. I'll move back over to the robot, and I'll put it all in there and show you how it works all in place. Okay? Be right back. All right, we're back. I have already assembled most of it. I will show you what's going on right now. Basically, this is the bubble lifter platform with the plastic piece under here. The motor will sit in this area. I've dropped the rods through the linear bearings, and they just slip in from the top here. And I've got that opened up a little bit so there'll be a little play in there, so it'll be forgiving as it runs up and down. These are those feet I was telling you about. It'll come down and clamp right onto those feet. They're just sitting in there right now, but it'll be run down. Those will be a little bit loose too. I'm not going to clamp them down tight to the shelf, just to give these bearings, this whole platform, a little wiggle room. Don't want the tolerance too tight. This ring, top ring, will be positioned in the proper level, and basically the motor will hold it up in that spot. And then as the motor runs, it'll either go up and down and push the neck tube up, but at the same time, that linear bearing, the thrust bearing in there, will allow it to turn. And then the bottom one, of course, I have another bearing down here, and this ring will come up and sandwich the two. So you can see how that'll work. So, and then the motor will push it up and down on those guides. So I only need it to run 2 inches. The motor itself will sit right in here. See if I can get that in there with one hand. Like so. And you can see now that offset, it's in the farthest down position. It's riding right up in there. And I still got a number of it. I only had, like I said, I had to raise it 2 inches. And as that turns, that offset will come up around and push this up, like so. The 2 inches I need. All right, so that's about it. I have some assembling to do here and some wiring. It's going to be powered by 12 volts, and it's going to be controlled through that saber tooth I told you about. All right, there it is, and I will be back after I get all that stuff done, and I will show you how it comes together and how it runs. Okay, see you later. Hello everybody, I'm back. Please excuse my crappy lighting. I'm in the dark room and I'm making do with what I got. So I got shadows and reflections, so bear with me. Hope you can see okay. I have got everything all hooked up now and the power is all run. I got my control system in place, and I'll kind of run you through what I got here. Like I said earlier, I've got 3 stanchions with linear bearings running up and down on them. Whoop. Okay, that was something. What happened, I think, is I lifted up the weight off of the motor, and my saber tooth recognized that and kicked in and tried to compensate. So we won't do that again. But I do have my computer hooked up to it through Easy Builder. Actually, that's called ARC now, and it's being controlled by a Easy B up in the head. I've got everything all rewired up there, and everything is copacetic. Okay, getting back to what I was going to show you before the motor took off on me. Let me explain some of the stuff I have on here. First of all, I have the lifting platform, like I showed you before. Back here, I've got the slip ring back there, and the collar, and with the thrust bearing in the middle. Here I have some limit switches set, so when the platform drops, it'll hit the limit switch if it goes out of control, up and down. Once the kangaroo is all set up, let me bring that around so you will see what I'm talking about. There's the kangaroo right here. It's a little daughter board that attaches to the saber tooth. And once this has been tuned, those limit switches will never hit because the range is going to be right inside of them. Let me bring this back around. Now, this is the worm gear driven power window motor from a car. And this is that round offset wheel I was telling you about earlier. It's set offset on a hub back there. And the hub I showed you before was 3 inches. And with the 3-inch round, I couldn't get this to lift the full 2 inches. Probably because of the way it's mounted here, how far back it is. So I had to change this to a 4-inch wheel, which lifts it exactly 2 inches now in between these limit switches, and I get the full up down. And because I did do that, I had to cut a slot in the bottom of my CSS shelf there to let it pass all the way around. Okay, now that's basically it. When the wheel turns, it lifts this platform, and it raises the platform the desired amount according to how I have it scripted, and it runs on these stainless steel stanchions here, rods on linear bearings. So let me start this thing up. This is arc. I've got a lot of scripts here, and I'm going to start the bubble lifter, just so you can get an idea of what happens. So you can see how that runs. Just got a little script written to bring it up and down. Let me spin it around so you can see the other side. I still have a lot of cleaning up to do with the wiring, so ignore that. Alright, pardon my shadows. So in addition to everything else, one last thing I want to show you is that is the potentiometer, the linear potentiometer from here to here, and this rod goes up and down and is measured, and down here the apparatus measures the voltage as it goes up and down. And it's attached to my platform, so the kangaroo knows exactly where the platform is. The kangaroo's over there. And that potentiometer will tell the kangaroo exactly where this platform is up and down and how fast it's going. So that's what gives it that's the feedback for the control. Let me bring it about a little bit more. There we go. Now you can see how that wheel works. I just got a little script lifting it up and down. And from the top, there's the bubble that it's lifting. Okay, now what about the radar right there? That'll go around too, and it will allow, once it turns, it'll still allow the bubble to go up and down. With me, here we go. And this is what's going on down here. So that neck pipe, if I don't get my finger caught in there, goes all the way through that platform, and it slides on that little slip bearing that I made, that I showed you earlier. And then there's a thrust bearing in there that's got needle bearings in it. And that little collar kind of rides on top of that and is held in place with a bolt. So, that's the whole thing in a nutshell. These, my finger caught me. These uprights, they do move around a little bit. I have them in there. I don't know if you can see them moving. Move just a little bit, just to take up some slack and slop that my imprecise measurements caused. So anyway, this is all hand built, and it's not CNC or cut precisely on laser cutter, so I needed a little bit of tolerance in there, I guess. So what I haven't done is I have not put the bottom collar and thrust bearing like I said I was going to do. I might still do that. That might be, I get a little bit of a shudder here at the end stroke. It might be because this thing is floating a little bit. But it doesn't really show up in the top here. So I might just leave it. Okay, well there it is. My hybrid lifting bubble lifter platform. And I want to thank again Greg Loge and JP Sale for the ideas that got me this far. Kind of copied what they had. And I don't know if it's improved, but it works for me. Okay? So, until next time, I will see you guys later. Okay? Happy building. Bye-bye.